I'm Chris Williams. I'm an assistant professor here at Virginia Tech. I direct what we call the DREAMS Lab, which is an acronym for Design, Research, and Education for Additive Manufacturing Systems. And in that lab we have several different technologies where we perform research on product design, materials research, process improvement research, and applications. We have a Connex 350, which is a great machine for us that can do multiple materials. That was the reason why we purchased that machine. We use the machine a lot to support other researchers and their research endeavors to make custom complex geometries that can't be made by traditional means. We had a lot of researchers who wanted to do small features on their parts that other technologies just could not reach. We kept finding that researchers would come to me and ask, what's the smallest thing I can print? What's the smallest thing I can print? And when I was saying a millimeter, that wasn't good enough. So the reason why we went out and purchased an object was because it offered the highest resolution that we found on the market. We also were very excited about the multiple materials, the digital materials that the Connex offers. That's something that no other technology offers. And of course, our business is education. So we bring the technology to the classroom, and we bring the classroom to the technology. And we get students involved and get them to learn about the new era of manufacturing and get them to use the technology to make their projects. I think the thing that excites me the most about the Object Connex and the way in which we use it here in the DREAMS Lab, we're not only able to selectively place material where it's needed most, but now we can actually tune the material properties. That's a whole new era of design that's never been able to be explored before. And so it's to our students' advantage to go ahead and be exposed to that concept so that as they go into industry and become designers, they can look for these kinds of technologies to really create new and innovative products. Let's go down to the lab and take a look at how the students have used the Connex in multi-materials and really unique ways. This is a car bumper that was made for an autonomous ground vehicle that some research team on our Department of Mechanical Engineering has been working on. And this is the original aluminum piece that they used. And of course, a bumper is a consumable part. It's used over and over again. That's the first part that's damaged, the first part that has to be replaced. And to replace this part, which is just an aluminum piece of sheet metal that then has to be hogged out, a lot of waste material, has to be replaced very often. And it takes a day or two to actually make. Now, so my students came to me and said, well, Dr. Williams, can't we just print this part? And so we took their existing design and of course printed in plastic, which of course this part was not designed to be made in plastic. So of course it failed. But what we then taught the students, and we stressed to our emerging engineers, is that you can redesign the part to take advantage of what 3D printing can really do, which is very complex geometries that just can't be made by any other means. We were able to make a bumper, or replacement bumper, that can be printed in just 2 hours or so, and is just as lightweight and just as strong for their robotic car application. And of course, we needed a high-resolution three-dimensional printer that could be made to make such fine detail. And of course, Object Connex was our choice for that. We're here with 3 students from my additive manufacturing graduate course. And here they're displaying a model they made in the class. It's an anatomically correct human elbow. And what they did was they used object material, multi-material capability to make a bone along with ligaments and other tendons that mimic an actual human elbow shape. Now the application here is they're actually trying to create a robotic humanoid and also to look at potential anatomically true prostheses. And only, of course, multi-materials can do such complex geometry and complex materials. Here we have 2 students in our micro robotics graduate level course who are showing how they've used the Connex and digital materials to help make their final project. Here their final project was a robotic inchworm where they actually used digital materials to mimic pads, little feet. The feet are actually down to 200 microns, which is a resolution that almost no other 3D printer currently available on the market can reproduce.
My name is Jake Soha. I'm an assistant professor in the Department of Engineering, Science and Mechanics at Virginia Tech. For years I've been trying to understand how it is that snakes can fly. So what are the aerodynamic principles? What are the biomechanical principles? What are the basic mechanics of how you can take a cylinder and turn it into something that moves through the air? The reason we chose to print this in 3D is that the geometry is fairly complex. Without the object machine, I'm not sure what we would have done. Probably would have crafted a model by hand, which is time-consuming, and you don't get the kind of uniformity that you have here in terms of the cross-section. So it'd be okay, but I wanted something that was great, and I think this model is great.
The Object customer support has been very good. We've been very pleased. We've had several other machines installed on campus, and even though they're there installing for another customer, we've still received phone calls from our customer support to sort of check in on us and make sure we're doing fine, which has been nice. It's a nice touch. The Connex has been a reliable machine for us. We take very, very good care of it because it's so important to our program and to our research program and our educational programs. But we have had no issues with the machines. One of my goals as an educator and someone who's very excited about 3D printing and does research in 3D printing is to get students to go out into industry and ask, where's our 3D printer? This is something that's used in the real world that gets them excited and lets them know that they're learning something that's of value. It's something that might be a competitive advantage on a resume. Our return on investment was mainly about research. It was purchased primarily for a research machine, and so we knew that it would allow us to create artifacts, create parts, create unique geometries that couldn't be made by any other technique. And it would allow us to go out and write more competitive grants to show prototypes or to show that we were able to come up with really unique ideas, especially with multiple materials. So we felt that we were going to be more competitive that way. On the educational side, it's our job to educate the students and to show them that these manufacturing constraints that have existed for decades no longer apply and that they need to rethink the way in which they design products. And 3D printing is the technology to make that happen.